you. Actually, I'm representing my supervisor. He has the grant, and he just couldn't make it. Yep. Yeah. I just don't take credit for his work and his hard work. So yeah, you know, throughout this entire meeting so far, we heard a lot about this idea of structure-function relationship and how it's very important for molecules. That is, if you know the structure, you can sort of infer what the function of the molecules are. Give an example. I know a lot of you guys are all experts in this. I'm a physics background, so bear with me. As an example, with proteins, how you do this, you figure out what the sequence is, and then from the sequence, you can sort of infer what the macrostructure is, and then finally, you can determine what the function is. And it turns out that we're really good at doing this, right? But there are other classes of biomolecules, such as, for example, glycans and carbohydrates, that should deserve some consideration. And it turns out that we're still stuck at figuring out the sequences of glycans in general. And part of the reason why is that, part of the reason why is that the building blocks to build these glycans and carbohydrates are quite numerous, even more so than what we have for, say, proteins. And not just that, that they can form not just linear structures, but also branch structures. And it is precisely because of this heterogeneity and the fact that they're quite super flexible, it makes studying this biomolecules, say, through ensemble averaging very, very difficult. So yeah, what do we do? And this is sort of where we come in. But so to sort of take a step back, it would be really nice if we have a method to deliver these whatever molecules that we're interested in into a controlled environment for measurements. And Electrospray sort of fits the bill for us. But we also would like a tool to be able to probe at a single molecule level these molecules that we're interested in with almost sub-nanometer resolution. And in this case, scanning tunneling microscopy also fits the bill. And so I'm sort of already telling you what the workflow that we have in our lab is that we use Electrospray to bring our whatever molecules that we're interested in from the solution phase to gas phase. We pass this through some mass filter where we can essentially purify our beam by getting rid of all the stuff we're not interested in and focusing on the stuff that we are interested in. And the outgoing ion beam, we can direct this to a sample or substrate. And it's really important that we make sure that we land these molecules as softly as possible on the surface to prevent any fragmentation of these molecules. And once you have that, you basically bring this sample with your molecules of interest to your microscope where you can do some cool imaging. So as a proof of concept, As proof of concept, we wanted to use this workflow to study linear polysaccharides such as chitopolymers. Essentially, these are composed of two kinds of monosaccharides, monosaccharides with acetyl groups and without acetyl groups. And if we do this, put this on our surface and try and images, we get an image like this. For reference, this polymer is about 20 nanometers long. Of course, it's very difficult to tell what's going on. We can do some image analysis and filtering, and we can see something like this. And if you trace along the polymer, you'll see protrusions going perpendicular to the polymer length. And essentially, these are what we identify as our acetyl groups. So we have a molecule, we can identify where the acetyl locations are along our polymer, and essentially can figure out what the acetyls, what the sequence is for such a polymer. Of course, this is just one image. We are doing more and more. And if you would like to know more, please come by to poster number 17. Yeah, thank you.